Hey guys, welcome back to my YouTube channel, Study with Shakira. So today we'll be reviewing AP Statistics Unit 4. So first off, some definitions. Random process generates outcomes that are determined purely by chance. Probability is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of trials. The law of large numbers is if we observe more and more trials of any random process, the proportion of times that a specific outcome occurs approaches its probability. So as number of trials increase, the experimental probability reaches a theoretical probability. The experimental probability is based on actual results from an experiment or trials, while a theoretical probability is based on what should happen mathematically, assuming everything is fair. A simulation imitates a random process in such a way that simulated outcomes are consistent with real-world outcomes. A sample event is a list of all possible outcomes. So probability. Probability of an event is number of times an event occurred over the total number of time of possible outcomes. So a general formula is that you should know. It's not on the reference table though, but it can be explained through Venn diagrams. For this formula that's always generally applied is that PA complementary equals 1 minus PA. So to visualize this, PA is all this. This whole circle is PA. And now, complementary means basically everything that's not PA. Everything else that's not PA is the complementary. So we could just do 1 minus PA, because if we remember the whole thing, the probability is 1. So this is the other general formula you should memorize. So PAUB, that is basically saying that it's either PA or PB, which is this. So it has to be the complementary of A and it has to be the complementary of B. So that means this symbol means and. So it can't be A and it can't be B. So the option is quite literally everything here. So that's why as the whole area is 1, we do 1 minus this part, the whole this. U stands for or and N stands for and. So this is given on the reference table. I'm not going to go over formulas that are given on the reference table. But the line is called conditional probability, which is B given A. Mutually exclusive is when two events have no outcomes in common and so can never occur together. So, probability of A and probability of B, they can't happen together, so it would equal 0. So, the Venn diagram would look like this, which also explains the formula. The probability of A plus the probability of B equals like the whole thing. The probability of is either A or B. Independent event. Knowing whether if event A has or will occur doesn't change the probability that event B will occur. So this formula, we need it. Like, remember this because you always have to check independence if you need it, if you're asked to. So this is how you check independence. Even if you feel like it's not, even if you feel like it is independence, you still have to check. And this is a formula. Once it's independent, we can apply this formula. We can multiply probability of A and B to equal probability of A and B. Only if it's independent, because this formula is in the reference table. So we know this must also equal this if it's independent. So that means the new formula is this. And then you could just multiply this on both sides. So it just gives you the formula. And like that, you just get the formula. So the probability model. We could do a Venn diagram, two-way table, or probability tree. We should use a Venn diagram like if it's overlapping with like events for U or N. Two-way tables preferably are more used if comparing two variables or categories, like a conditional probability. And a probability tree is often used for multiple steps or events happening in order. You can use any way, these are just the most preferred, easiest routes. A random number table, what is that? It's used when wanting to stimulate probability using randomness. So 1. Assign numbers to outcomes. Second step, use random digits to apply those outcomes. Third result is to count your results. Okay, so a factory produces light bulbs. 10% of the bulbs are defective. So we're going to use a random digit table, which usually has just a bunch of numbers. It's a table with a bunch of numbers. So we're going to stimulate 3 trials, so at the sample size of 10. So first off, we're going to 10%. All the numbers are from 0 to 9. So 10% from these digits would be just one of them. So we could just assign 0 as defective. Now, to ask for 3 trials, we're going to use 3 rows and with a sample size of 10. So each row has 10. So now we're going to look through each row which has the sample size of 10. Make sure you're looking out of the sample size. So not 0, not 0, not 0, not 0, not 0, not 0. There is a 0, so it is at least 1. So that is defective. I'm going to try D for defective. Not what? Oh, already at least 1 is defective. And now row 3, already 1 is at least defective. So it was 3 out of 3. So the probability is 1. Also, make sure when you're writing it, make sure that you say that the probability would be 1 for a sample size of 10, and also beware that it's only a small number of trials, so it may not be fully accurate. Now, often a question asks how you would use your simulation, so describing it. So number 1 is to state your purpose. We want to estimate the probability that. Second is to describe how you model randomness. Assign digits to outcomes. Outcome A to blank, outcome B to blank. Explain how you run one trial. Random digits will be selected one at a time. Each set of blank digits represent one trial. There are blank trials done. Explain what counts as successes. A success occurs when, and then 5, repeat. The simulation will need to be repeated many, many times to estimate the true probability. So I included, based on the example we did, in the parentheses of what we would input there. So describing how to carry a simulation for like any type of test really is first we always state what you are explaining. We are simulating the probability that. Second, how randomness is created. What did you do? Did you assign digits, shuffle labels, random assignment? 3, what one trial is. One trial consists of. 4, what counts as a success. And then 5, repetition. Repeat many, many times to find the true proportion. So, now, transformations. We went over this in Unit 1. So keep this in the back of your mind, because it applies to this. If we add or subtract to the mean, it gets affected. As stated before, when we add subtract from every value in the data set, the center increases or decreases by A. Also, if we multiply/divide to the mean, it also gets affected. If we look to multiply and divide, the center, the mean, also increases and decreases by a factor of B. So, if we add and subtract standard deviation, it does not get affected. If we look back, adding and subtracting, for the spread, the standard deviation stays consistent. For if we multiply and divide to the standard deviation, my bad for putting mean, it gets affected as well. As we go to multiply and divide, we see the standard deviation, the spread, does increase/decrease by a factor of B. So, shape always stays constant, and that continues. So, combining. When repeating, it's when you repeat a random variable or combine 2 or more random variables. In order to combine random variables or repeat them, the variables must be independent. You have to check if they're independent first, and then you can apply these formulas. If you're adding or subtracting 2 different random variables. Probability for discrete. So, the expected value/mean. This is on the reference table. And this is an example. So for example, using the formula to get the expected values, also known as the mean, is basically x, so the value, let's say 6, and then the proportion of it, so let's just say it's 0.5. So the expected value would just be 3. And then it's for the sum, so if the next value is also that, it would be 3.5, and they just add them. Also, standard deviation is also given on the reference table. And this is how you would format it, after the same format we always use to describe standard deviation. So, binomial. Binomial setting involves repeated trials of a random process. So, bins, remember this. So B stands for binary. It means only 2 possible outcomes. So it's either a success or a failure. I stands for independent, trials of some random process. Independent trials of some random process. N stands for number of trials is fixed. And S is for some probability of success for each trial. And the formulas are also given on the reference table. And also we see here that this can also be inputted in the number calculator. If you're at the number calculator and you press the toolbox, you would scroll down till you see probability. And then we just stated how this is combining. So we just put the combining one. And then we see NK. And then we just input the formula. Geometric. Geometric random variable is the number of trials it takes to get the first success. So, geometric setting. The other ones was bins, and now geometric is bits. B stands for binary. It only 2 possible outcomes, success or failure. So it still has to be binary. And then I stands for independent trials of some random process. T stands for trials till success, which really makes the geometric distinct from the other one. And then S stands for same probability of successes for each trial. So the formulas are also given on the reference table, which I will not be going over. But also it makes sense if we look at the formula for to the left, 1 minus p to the power of x minus 1. That represents the amount of times you're not getting successes until p, which is the success. Probability for continuous. There's a normal distribution and uniform distribution, which both describe continuous data. And the area under the curve is always the probability.
Like and subscribe and comment.